So expecting the Germans or any of the Europeans to talk the same was ignorant on my part.
Look, I'm just being, I would say, historically respectful to the names. Like I pronounce a person's name, with using the original pronunciation. Why would I mispronounce? Like, why would I mispronounce someone's name? That's my position. Like,
So is it Einstein or Einstein?
I don't think his name. Like, if you met him, he would have said Herr Einstein. That's how you would refer to him, Herr Einstein. That's how I refer to him. All right. So I think we're
Say my
live.
name. Say my name.
What's your name?
Say my name.
I'm not. Let me look.
Heisenberg?
Where is it?
Say it.
Dan the
Marcus.
Waterman.
Say it.
Akdemak.
Oh, you're so bad. Ugh.
Akdemak.
Dimok. Learn your German, dude.
Akdemok.
Damn.
Hmm.
You're slow.
Yeah, very slow. Nevertheless, who wants to debate the topic? Proposition is.
Can you say my name, but the numbers are in Finnish?
So I'm proposing a debate. Can we explain? So I claim we can indeed explain the stern-gerlach experiment using classical mechanics only. Does anybody want to?
We.
Who's we? What? We? Me. Me can explain.
We.
Me can explain. Yes, the room is very quiet. I move to closing. I win. Round 2. Does anybody want to? Like people think. Like everyone thinks. Like every YouTube video I watch.
I can prove everything.
Excuse me.
So
Quantum.
I think
no one
that
said anything against, so I win.
I don't think you debated Sea Lion on your statement about the global financial crisis.
You don't think? Well, there is a.
Well, I mean, my understanding of that discussion was that you didn't back up your claim. You demanded that he have an all-encompassing theory of economics.
Correct.
And I don't consider that to be like, why would I want to debate you after that, since I think you clearly lost and and made no sense for the part that you did speak.
Okay.
You're
So
saying he's a dishonest interlocutor.
Well, I
that's
Weasley, maybe.
let me just say that dishonest would be kind for what I think.
okay.
Happened there.
All right. We're not going to attack me because I don't want to waste my time. So please stop attacking me.
Well,
So you can, Mr. Forgot your name.
Omnivore.
I'm sorry.
He eats everything. He eats everything.
Mr. Omnivore, you think I lost the debate with Mr. Lionheart. So why don't you then debate? Let's debate right now the same topic, the same contention.
Well, I mean, so sure. So what is your rationalization for thinking that the 2008 financial crash was either not real or created by the government or whatever nonsense position you had?
Well, without the nonsense position, because I would take offense. I'm not going to refer to anything you say like that. So let me just. I was going to just read my contention, but you pretty much said it. So, but let me read it anyway because I don't want to. Let me read at least the beginning. So, no financial crisis, because you said financial crash. So I don't know what a financial crash is. So
Jesus
2008
Christ.
definitely
You're fucking stupid. I'm out of here.
Yeah.
Just
Yeah,
try-
2008 totally qualifies as a crash. Holy shit. Entire banks, went bankrupt.
I'm
Entire
Oh, whatever.
I'm not
whatever,
denying.
finishes.
I'm not denying the facts. I'm not denying any facts. The question is, the last statement of my contention are these words: these events were never organic. So I compared the 07, 08 and the 1930s depression or any other financial event like a downturn. I would claim any downturn you show me since the beginning of time. And I would say that cannot be that cannot be and obviously was never organic. Those things can always be compared to the schmovid. I'm sorry that I have to say schmovid because I'm streaming on YouTube, and if I say those words,
Okay,
they'll take
So-
alright.
So what is your reasoning why they're not organic? Because economics tells us that
Well,
the
ju- 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 ju-
business.
ju- ju- So
Okay.
so the sea lion debate. He said that there's market cycles.
Yes, what I was going to
Mr.
say.
Slave demanded that he explain, a coherent theory of all financial cycles, or else he would win the debate. And he, since there is no single coherent theory of all financial cycles that anybody agrees to and has an understanding of, other than the one that Mr. Slave has in his head, apparently, Mr. Slave claims he won. However, what he didn't show was that it wasn't organic. So, yeah. So, what makes you think, when you say organic, are you claiming that it was planned? When you compare it to Schmovid, are you claiming like the plandemic?
No.
What is your position? I mean, I'm not clear what your position here is.
That's a good question, but let me just first explain why I won the debate. Not that I care. I honestly don't care.
Oh my fucking god!
Yeah. Okay. Look, if you're not going to do it, you're not going to do it. All right.
Do what?
I gotcha.
Wait a minute.
Have the debate. Explain yourself.
Wait,
What is your position?
you brought up.
Is your position that these were fake for some reason, like some nefarious reason?
No, I already said no. But before that,
Okay, so then
let me speak
what
freely.
do you mean by not organic?
Look, you have to let me speak freely. I let you speak freely. I'm not stopping you.
Actually, we don't have to let you speak freely.
I didn't say you have to. I'm just saying I'm letting you speak freely. You're not letting me speak freely.
Literally said you have to.
Yeah,
Anyway.
you already said that. The reason why I want you to hurry up and get to the point, because otherwise it's a waste of my time.
No. So I will speak freely. And if you want, you can abandon the debate. It's up to you. Nevertheless, my point being that,
Don't shout.
look, about the debate with.
Fucking annoying.
Yeah,
Keep going.
sorry about that. Anyway, about the debate with Senor Sea Line, the Honorable Sea Line. So during a debate, he brought up some sort of cycle.
Wait, no, stop.
No.
Omnivore asked you to explain your thesis.
Right.
And you're going off about the debate the other day with Sea Lion. No, we want to hear, your thesis.
When you say they're not organic, what do you mean by that?
No, but hold on. Omnivore, you keep bringing up the debate with Sea Line. So anytime you bring it up. But look, I didn't bring up Sea Line. I don't care about Sea Line. You keep bringing up Sea Line, then
Yes, the reason why I brought up Sea Lion was because the way you comported yourself during that debate makes me extremely unlikely to want to debate you. However, there is a possibility that if you're willing to comport yourself better, then maybe we could have a discussion about it. So but that would depend on what your theory of case is, which you won't say. When you say not organic and you compare it to the pandemic, I think of things like the quote unquote pandemic, which is, as far as I'm concerned, rank conspiracy nonsense.
I already answered. I don't believe in the notion of a pandemic. But
Okay,
before,
so then what do you mean by not organic?
let me just have my tiny piece about you.
You're not going to answer it, are you?
I
You're
I
not going to
said
answer it.
I will, but all in good times.
No. How about
Yes.
like now?
No.
Not 10 minutes from now. Now.
No. I will speak my mind freely, and you will not interrupt me. Nevertheless,
You got a
and
few minutes. Go ahead.
all right. So look, let me be short about what happened with Sea Lion. It's really short. Let me just say,
No,
yes. You brought it up. I will speak freely. Nevertheless, so look, it's really short. Let me just say it, and let's move to
get it out. Get it out.
yes.
Get it out.
Let me just get it out. All right. So look, what happened with Senor Honorable Sea Lion was that he brought up a cycle, like some sort of credit expansion contraction cycle. Now, I believe that that is a conspiracy theory that to me is belief equivalent to a belief in a flat earth. When people bring up these cycles, I know they are flat earthers when it comes to economics and finance. So I wanted to finish him off in this debate, and I asked him to explain what causes these cycles, knowing that these cycles don't exist, therefore they don't have a cause and effect because they simply don't exist. When he refused to answer the question, I asked again, he refused. So I think it happened twice. So clearly he was unable to answer the question. He explained he's unable to answer the question of words that he brought up. So as they say, he literally doesn't know what he is talking about. Right? He brought up this cycle.
All right. Enough. We got it. We've got it. So what is your position on organic? What do you mean by organic or not organic?
Well, it's in the let's read then. Let's read the proposition that is in the side chat. So no financial crisis has ever happened 08, 7, 30s by all metrics. Schmovid is indistinguishable from 07 financial crash. Oh, I also called it financial crash, so it's fine. Which in turn is indistinguishable from the 1930s depression. And I would add it's indistinguishable from any other downturn. Continuing reading the proposition. This indicates that as the Schmovid downturn was completely manufactured, I'm not saying planned. I mean, obviously it was Trump, and I support.
What do you mean by manufactured?
No. Listen, yeah. Look, I support Trump with all his failings. I do support Trump, so I don't think that he. Anyway, we'll come back to what he did to.
Well, there's less I could think of you.
It doesn't matter. Please, don't reference me, please. Anyway, I'll continue reading. So this indicates that as the Schmovid downturn was completely manufactured by governments having had shut down the world economies, so did these other downturns were manufactured by government having had shut down the economies. These events hold on, let me one more sentence. These events were never organic. So that's what it means. That's what when I say these events were never organic, it means it's government shut down the economy. When I read through, let me
all right.
Let me continue.
All right, listen.
Yes,
we're getting dangerously close to ditching the whole thing and going on to something else.
Well, that's called then you'd be disengaging.
Yeah.
And I would
we don't care.
closing.
No, the problem is
It's
that
recorded.
you're not willing to say what your position is, and that's the only thing that I'm interested in, because after your discussion with Sea Lion, the way you comported yourself
again, you bring
makes me
again
unwilling.
you bringing up
Because it was bullshit, and I'm letting you know it was bullshit. All right. So, are you willing to say what your position is on what you mean by manufactured or not organic?
I just did. Governments shut down the economy. What's
Yeah.
not clear about right? You agree that in Schmovid, governments shut down the economies worldwide. I mean,
Yeah, but
you're
they
not going to
didn't.
disagree with that. Or maybe you are. I don't know. Do you
Yeah,
think
but
Schmovid?
other depressions and economic downturns were not the
Well,
government shutting down the
Well,
economy.
hold on. Are you saying that because there was a viral pandemic in effect, the necessary precautions that governments instituted for the health and safety of their people is it makes it not organic?
No, I'm not. I don't want to get into the reasons for governments. Was government doing well by shutting down? Was it good to save lives and so on? I'm not going there. I'm just saying that when you look statistically speaking, scientifically speaking, you're comparing scientific phenomenon such as the Schmovid downturn to the '07 downturn. When you look at the scientific metrics, these two scientific phenomenon look identical to me. I don't
but
see
that's-
the yes.
Yes,
go
but you're a clown because the government didn't shut down the economy in 2008.
so I was there, and
I was there too.
yes,
It wasn't the government. It was a collapse of the banking sector. It was a collapse of trust. You don't have a fucking clue what you're talking about.
Okay.
Yeah. So
Yes, I'm listening.
Yeah.
Good title.
What
Yes,
do
it
you
was
what
the
do you think?
collapse.
What do you think the government action was that shut down the economy during the 2008 crash?
Okay, I'm not going to debate 2 against 1. If I am, then it's not.
Well. So listen. What we're trying to do is figure out what your position is on these, and like I said, you won't say.
I said I will not debate 2 against 1, and then you cut me
Right.
off. Again, you cutting
Yep.
me off. Again, you're cutting me off.
Yeah,
So,
because this is painful, and
well, maybe don't cut.
It should be embarrassing for you, but probably
Should
not.
we move away from economics to go back to his claims about the stern-gerlach experiment?
That would be considered a disengagement, and I would move to immediate closing.
I'm asking Omnivore if that's what he wants to do.
I'm not interested in his. I asked him about Compton scatter. He provided no answer, and so as far as I'm concerned, his theory of everything is falsified, and he has seeded the field. So, he didn't know what Compton scattering was. He got hit with the Compton scattering, and he fell apart. So
anyway, what do we?
I see no reason.
Okay,
to debate you. Well, what government actions do you think precipitated the 2008 market crash?
Okay, so you cut me off as I was speaking, and I will.
Yeah, I'm asking you a specific question to see if I even want to continue having this discussion.
No, I will speak freely, just as you speak freely, and I will say my piece, and you will listen, or you will lose. Nevertheless, anyway, so I will not debate 2 people unless if one speaks.
I like how you think. I like how you're so incredibly arrogant that you think you're actually in charge and can bully the channel owners around.
I'm sorry. Okay. I'm gonna stop. Okay.
What the fuck was that? What the hell was that?
That was so horrible.
What was that?
I'm sorry. That's me. I'm sorry.
That laugh alone should deserve him a mute.
I think that was his symbiote screaming.
I'm sorry. Look, I don't want anyone to feel that I'm bullying them. So, okay, I'm gonna stop bullying. All right. Let me just say one thing about debating multiple.
Just nut up and say, cowboy up and freaking say what you think the government did to cause the market crash.
But Omnivore, please stop. Like, I let you speak freely. Please just let me speak freely. So
because when you're speaking freely is boring and ignorant.
I'm talking about the protocol, the way in which I am willing to conduct this debate.
The way you conducted yourself with Sea Lion was, bottom tier.
I'm sorry.
So
I'm sorry about that.
I mean, I'm letting you know that you're
I'm sorry.
you're not providing a impressive. You're not providing good content.
I'm sorry. You're right. So, nevertheless, look, about debating multiple people. So it's fine as long as when one, let's say it's 2 against 1, 2 of you against 1 of me. So one of you speaks, I get a chance to respond. Then the other one speaks, I get a chance to respond. It can't be that one of you speaks, I don't get a chance to respond, and then the other one speaks, and then I get a chance to respond to both. So that I consider that to be dish galloping.
Are you
So,
actually going to respond?
Of course. A day will come and I will respond. Anyway,
Yeah.
So look, in 07, 08, the government interfered enough to cause fear in the markets and to create and to cause the markets to seize. And people.
Now what?
I mean, the government started investigating bankers, brought bankers to be cross-examined in front of Senate and Congress, and
Before the crash?
no, after. I'm talking about after.
Yeah. So what happened? What happened? What did the government do that caused the crash?
He thinks that the government investigating after the crash caused the crash. That's how fucking stupid he is.
That's the impression I'm getting.
Right. So just look, this is you can compare it to, of course, the 1930s, because again with
specific question still on the table. Go ahead and talk. I'm going to ask it again when you're done.
Thank you. Anyway, look, the 07, 08, I don't even know what year. I mean, if I ask you, is it 07, 08? When did it happen? I mean, I have.
It was the fall of 07, carrying over through the election of Obama. In 08.
Okay.
Obama.
If he can't tell what year the market crash that he's talking about happened in, then I think that's automatically ceding the debate, right?
And it was
his
global. It was a global downturn in financial markets across the globe, not just the United States.
Yeah. Okay, so hold on. So keep going. Go ahead and say whatever thing you're planning on saying, and I'll ask the question again.
Again, you're speaking 2 against 1. It's going to make it impossible.
If you haven't, well, you're try and answer the question.
I can't. I mean, if it's going to be 2 against 1, I need to be able to retort between you two. Otherwise,
but you're not addressing the question.
Yes, you keep cutting me off. You're dish galloping and claiming I'm not answering questions. Yes, it's a good technique. That's a logical fallacy. You need to stop.
This is interesting.
Anyway, look. So, with the 1930s, I don't even know. Like in 1929, you could say there was a financial crash, but during the 1930s, there was a Great Depression. So it's like, what's going on? Why so many years? What happened? And when you look at the actual statistics, 1929, yeah, there was a crash. I mean, what crash? The prices.
All right, this is kind of bullshit.
You want to move to closing?
Well, I don't think we ever got through opening.
Yeah, you're just not answering the questions that are being asked of you. You wander off into another subject.
Exactly.
Look,
so we win, you lose.
Look, my point is, in 1929, you could say there was, because you brought up a market crash. Notice I didn't bring up the markets. I don't think I brought up the markets in my contention, in my proposition. So I agree there was a so-called market crash. Even that didn't happen. All that happened was there was a price crash. The price of housing crashed a little bit, not even when you look at the actual numbers, it's about 25%. The price of housing fell about 25%. That's all.
There were 25 million people out of jobs.
Yes,
just let
exactly,
him
exactly.
continue.
And
None of this.
No, this
He's
is
not saying anything relevant.
No,
Let
no,
him
no.
continue. I'm hoping he'll
no.
say something
I'm
relevant.
explaining to you the mechanism. So look, you can
You're not
have
explaining the mechanism.
no. Look, 1930s, the market crash. There is no such thing as a market crash.
I don't care about 1930s.
Well, it's in the proposition. So if you don't care,
Yeah, I know.
What do you
and
mean?
You've had so little to say. Your position on this is so weak that I'm wondering if you've actually got a theory of case.
Well,
And I'm beginning to believe you do not.
well, you can move to closing. You want to move to closing? It's up to you.
Yeah, so he can clearly not show any action that was taken by the government that caused market crash, which was his apparent thesis, although he won't say for sure.
Well,
So
I'm going in closing. I will
obvious
just
bullshit.
Yeah, in closing, I'll just say you keep cutting me off. So thank you very much for not allowing me to speak my mind. Let's move to another topic. What else do you want to discuss?
Alright.
Do you want to discuss quantum mechanics? Because obviously, when it comes to finance, you're not going to let me speak. So yes. So you think that quantum mechanics, and it's also more important to me. So you feel that I cannot explain the stern-gerlach experiment using classical mechanics.
No, I
only.
think you can't explain Compton scattering.
Yeah, we could do that too. That's fine.
Go ahead, do Compton scattering.
Please hold on. Let me just first paste this. Let me make sure. What is this? I'm added to crazy groups. All right. What's your proposition? I never. So you feel that the Compton
Compton scattering does not come out of the wave equations. Therefore, it is only explained by particle behavior quanta.
Wait a minute.
Proposed by quantum.
Compton scattering. I don't know. Compton scattering, yes, cannot be explained. Right? Cannot be explained by the wave equation.
Yep.
Okay. The wave. I mean, I don't remember I used the wave equation, but we'll go with that. Let's say wave theory.
Last time we talked, you didn't know what Compton scattering was.
Sure. I mean, you explained it to me. I appreciated that. Anyway, so cannot be explained. It's not that I didn't know. I just didn't know I didn't remember the name. Of course, just before that,
He knew. Yeah, he knew all about it before Omnivore, but you just reminded him of the name.
I mean, it's in
Compton scattering.
It's in my history.
History.
It's in my YouTube history that I watched it.
Yeah, and you're an expert on it now, aren't you? You're an expert.
It was explained to me, and I feel I have a good mechanical grasp of it. So I don't care.
Yeah.
Mm-hmm.
Bet you do.
Yes.
It was explained to you colloquially, and now you think you know everything there is to know about it.
So for the audience, can you explain what Compton scattering is?
Wait. I'm just typing the proposition. Compton scattering cannot be explained by the wave. I would just say by Well, you don't want to say classical mechanics because I just prefer that.
No,
it would make your case stronger, right? Because you would say that I cannot. Wait, what?
Nope.
Oh, because
you asserted
that I understand.
That wave equations could provide for Compton scattering, and the answer is no, they don't.
Look, I just have a theory, like what do you call it? The ether, right? So I'm just going to explain it using ether. I don't think I used the wave equation during our debate.
Well, you claimed everything is a wave.
Yes.
And when I challenged you on Compton scattering, you said, well, the wave equations can explain it, can't they? And I said, no, they cannot.
Wait, I asked you?
And that
during a debate, I asked you?
Yeah.
Okay,
yeah.
so that's not...
It wasn't a debate. It was you not knowing what we were talking about.
Okay. So cannot be explained by ether.
But yes, you actually had to ask a question because you asserted, clearly not knowing, that Compton scattering could be explained by the wave equations, and they
It's
are
not
not.
important.
That
It's
is,
not important. Look, I want to create
Well,
a
it was then.
proposition that we can both stand behind. Proposition. Just let's not talk about history. Let's talk about the current proposition, what we can now debate. So Compton scattering, I would say, can be, just to make it a positive claim, can be explained by the ether wave model. Somebody's hot miking. Lush, you're hot
Yeah,
miking.
I thought you were, but sorry, my bad.
It's fine. So proposition, Compton scattering can be explained by the ether wave model. How about that? Do you want to, right? That makes sense to you?
well, if you say everything is a wave, then I would say that's not true. If you say the ether wave model says that waves can behave like particles, then yeah, it's trivially true just by claiming that your ether waves can behave as particles when they need to, but they aren't really particles.
Okay, so
which isn't interesting.
Okay, I'll fix it. Edit message. Okay, so so in the ether wave model, where no particles can exist besides the very particles that make up the ether fluid. Are you good with that? Compton scattering cannot be explained by the ether wave model, where no particles can exist besides the very particles that make up the ether fluid. Very good. Yes. So I stand behind the positive, therefore I will begin. Let's remember Compton scattering. So we have a photon and it needs to scatter an electron. Right? Let's just get our facts together. So let's agree on the very experiment. What is Compton scattering? So we have a high energy photon that you would say is a particle. Am I correct? Yes, no? You want to help me? I just want to...
No, I'm not really. Dude, you burnt through a lot of goodwill.
Yeah.
I'll help you
Sorry.
out.
Look, you want to disengage from this debate too?
I'm not too interested in helping you out.
What do you mean helping me out? Okay.
We
need to agree. We need to agree on what is Compton scattering. That's in the proposition. So we need to agree on that. So otherwise, I don't know what to do. I mean, Compton scattering.
Well,
yeah.
You can Google it. You can Google it
Fine.
and look it up.
I'll accept your permission to Google Compton scattering. Compton scattering. I will still need your permission to accept the definition. Compton scattering, or the Compton effect, is the quantum theory of high-frequency photons scattering following an interaction with a charged particle, usually an electron, specifically when the photon... Let me continue reading in Wikipedia. Oops, it's too light. Okay. Okay, there is an image. Let me just grab the image, copy image. Here we have an image. So I put an image in the chat. So what we see is high energy photons, and I see proton scattering. What do they want? Okay, Compton scattering is the quantum theory of high frequency photon scattering following an interaction with a charged particle. So a photon interacts with a charged particle, let's say an electron, usually an electron. Specifically, when the photon hits electrons, it releases loosely bound electrons from the outer valence shells of atoms or molecules. The effect was discovered in 1923 by Compton while researching X-rays and earned him Nobel 27. Compton effect significantly deviated from dominating classical theories using both special relativity and quantum mechanics to explain the interaction between high frequency photons and charged particles. Photons can interact. Okay.
Tell you
All
what,
right.
come read it and come back.
No.
There may be other people who'd like to have a discussion.
No, I'm fine. Look, so we have a photon. We see in the image that is in the side chat, we have a photon. A photon, to me, is a wave. And that wave has momentum, according to Maxwell.
Hey,
I have to step away for a minute.
hey, I have a
Oh.
public service announcement, but it won't take long here. If anybody wants a different topic, I will be the other VC to help you talk about that topic.
Okay. Anyway, Mr. Omnivore walked away as I was explaining the Compton scattering. The photon is just a wave, but it has momentum as per Maxwell. Maxwell already showed us that a photon must have momentum because a photon is able to move charged particles. So, and Maxwell agrees that a photon is a wave. A photon is a wave. I mean, he didn't have photons, so to Maxwell, right? So Einstein's photons is Maxwell's electromagnetic waves, and Maxwell agrees that electromagnetic waves can move electrons that have mass. So even Maxwell agrees that light can move mass. So waves, electromagnetic waves, can move masses, massive particles.
We all agree. That's nothing new.
So why do you have? Okay, so that's the explanation. So you have a photon.
So
go ahead.
do Maxwell's equations describe Compton scattering? Can you use Maxwell's equations to show how Compton scattering works?
I could.
Nope.
Look.
You can't.
Wait. So Maxwell agrees that electromagnetic waves can move charged particles, right? It can create current, and current is the motion of a
You're
charge.
rambling.
I'm rambling. Well, you're cutting me off. I mean, I'm explaining it to you. You said I can't. You said can. You asked me, can Maxwell explain Compton scattering? I said yes. Let me try. I'm explaining, and you're calling that rambling. So, what do you mean? I just explained it. I don't know what else to do. I just explained, as I did multiple times before. I just explained how Maxwell can explain Compton scattering. I just explained. I don't know what else to do. Maxwell, yes, go ahead.
Try and find a derivation of Compton scattering from Maxwell's equations. You will see that you cannot.
I just said Maxwell claims that electromagnetic waves can create current. Somebody's hot micing. What is that? Stefan, you're hot micing. Stefan Mudd.
So it turns out that one of the behaviors of light that Maxwell's equations do not explain is Compton scattering.
I just did. I mean, you but you agree. Wait, Stefan, you're hot micing. Stefan Mudd. I'm gonna have to mute him. I'll just lower the sound. Okay. So
I think you mean stay phone mode.
What?
Mr. Mood.
Yeah, I think he stopped hot micing. Mr. Mood stopped hot micing. It's fine. Look, Omnivore, So do you agree, right? That according to Maxwell, and Hertz proved it. I mean, that's Hertz experiment, that electromagnetic waves created sparks in his remote antenna. And
Mhm.
those sparks are electrons. Electrons were moved due to electromagnetic waves.
Mhm.
So what's the question? So yes, electromagnetic waves can move massive particles like electrons.
Yeah, that's true.
So so that is Compton scattering in essence.
No, it's not. It's not.
Mhm.
I'm sorry.
Yes, I'm listening. I mean,
So
essentially, yes.
Compton scattering
Mhm.
is a billiard ball style effect where the photon reflects and has a lower wave, has a lower energy, and some of that energy is imparted to the photon, to the electron rather.
Okay.
And the angle of incidence is where it impacts it is proportional to the angle at which it reflects. So no, Maxwell's equations actually do not describe that.
Wait.
The
So
fact that they can show that you can move a electron with photons is not sufficient to describe Compton, what we see in Compton scattering. That is why we identify or describe photons as a quanta, meaning a particle-like packet of energy, rather than a wave, because Maxwell's equations won't get it done. I'm sorry.
you just asked me if Maxwell can explain. So I said,
Yep, and it does not. Right,
look, it's not
it doesn't.
okay. That's actually not part of the proposition. So I really should. I could say that's not part of the proposition. You asked me. I could explain it, at least the essence, the essentials.
No,
That's not. It's
You're
not the
right.
proposition.
You can explain something that you think is similar to Compton scattering, but isn't.
Look, you asked me a question during a debate. I gave you an answer. I could say irrelevant. Let's continue to the proposition. I cordially did you a favor and I answered your question. You
Nope.
claim
You
fine,
no.
it's irrelevant, irrelevant. Let's move to the
How
actual
does your
proposition.
how does your ether explain Compton scattering?
In my ether, if you look at the image in the side chat, that wave, even they show it as a wave. They show the photon as a wave, but it's a wave packet. It's a quanta wave. But it's still a wave. It waves.
It's a particle.
That's not what they show in Wikipedia. They show a wave. They show
a wave behaving as a particle.
Look, it's a wave that. What do you mean behaving as a particle? Because I agree.
I mean, literally,
because
that.
I agree.
It behaves.
Yes, I agree that a wave packet, you could say it has certain behavior that is. I mean, it maintains its integrity. It's a wave that doesn't disperse. It's a wave that
Right.
So
Correct.
but it's still waving through the ether, right? It could.
No, well, it's we don't know that it's waving through the ether. You assert that
Yes,
it's waving through the ether.
correct. I'm asserting, yes, but I can. The proposition is Compton scattering can be explained by the ether wave model, where no particles can exist besides the very particles that make up the ether fluid. I'm not asserting
Because you can claim that photons can behave like particles, even though you resolutely claim particles don't exist. That's trivial. And I told you that was where you were going to go with it. It's a particle, but it's not a particle. Yeah. Okay.
All
So
I'm
what did we
saying,
learn from that?
no,
Nothing.
no. All I'm saying is it's a wave that maintains its integrity. That's all. There's
Unlike a wave, unlike an ordinary
well,
wave.
it's
So what causes it to? What causes this bizarre maintenance of its integrity?
I don't know. I don't the
Right.
proposition.
Exactly. You don't know. Therefore, your model doesn't aid you with that, does it? It doesn't help you know. Your particle doesn't provide insight into how it could do that, right?
I mean, yes. I mean, look, the proposition says Compton scattering can be explained by the ether wave model where no particles can exist besides the very particle. Yeah, I mean, I don't see the issue. Of course, I'm able to explain. Even this Wikipedia image understands
Right.
my wave photons as waves. I mean, I
No,
don't even need.
no.
No,
No.
what's the question?
No.
So what
No.
do you? Mhm.
What happens is your model, your ether model, relies on just waving your hands and saying, yes, somehow photons are ether waves that behave like particles, which we already know. It doesn't provide any insight or any explanation.
No, waves in the ether.
Yeah, right.
Not
It's
ether
just
particles.
hand
Just
waving and declaring it. Yeah, you're
yeah,
just
waves
declaring
in
that it's waves in the ether.
the
Yeah.
waves. Electrons are waves. I mean, that is QFT. That is quantum field theory that says that all elementary particles must be waves for like there's. I
But
would
they
say
also behave like particles.
no.
Yes.
What?
That's what Compton
Because
scattering is.
no, because you're saying look, okay, let's get the definition of a particle out of the way. So I'm saying that in my ether model there are no particles besides the particles of the very fluid of the ether. So
Right.
I don't need any particles now. But the
Right.
waves.
So you just invented waves that mysteriously behave like
Yes.
particles.
Yeah. No, not like particles. They just maintain their integrity. I wouldn't
They
say
behave like
no.
behave like particles.
Okay, look, if
So
you
how do you distinguish a particle photon from a wave packet photon? How would we know if it was one or the
because
other?
a photon, for example, a photon can decay into an electron and a positron. And electrons and
Okay.
positrons can decay or
Is your argument that particles cannot decay?
that I wouldn't I don't know. Look, I don't know. Look, the question is, do we disagree on the science? That's my question.
I am not familiar with photons decaying. So
What do you
but
mean?
I'm not familiar with photons decaying.
A photon can
Maybe it can,
what do you mean
but I'm not
maybe?
familiar with it.
A photon?
Can you show me a citation? I'm not saying it. I'm not claiming it doesn't happen. I'm saying I'm not familiar that it does. So if photons are decay, if photons be decaying, drop me a citation.
Can would you accept if we ask ChatGPT? Is that good enough?
No, I want an actual citation.
Okay, so you can look it up. I'll give you ChatGPT. Let me ask ChatGPT. Can a photon decay into an electron positron pair? Question mark. Let's try that again. Let's refresh ChatGPT. You know what? Let me ask Brave.
It told you no, right?
Yeah, I'm a free person. I do as I will. You do as you will.
No. I mean, the ChatGPT told you no.
No, it doesn't
Oh.
work. It didn't work. So, based on
Okay.
research, it is not possible for a single photon to decay directly into an electron-positron pair. This is due to the conservation of energy and linear momentum, which cannot be satisfied by any reference frame. Wait a minute.
All right, let's move to closing.
No, I mean that's just one example. I mean, according
All
to
right. Look, you said, look, this is not good content. You said, you know, it's a wave that's behaving like a particle, except it's just a wave that maintains its coherency. I said, how we distinguish such a wave from a particle? You said, which is, I don't understand why it's related. Photons can decay, which, you can't substantiate. So even if that were true, I don't think we have a reason to think it happens the way you believe it does. And your ether theory doesn't provide us with any insight into how Compton scattering works with photons only being Maxwell's waves, which is what you tried to claim for your ether theory before.
no, that's irrelevant. I told you that's irrelevant. Why are you bringing it up?
That is what you tried to do.
No,
So.
no, you asked me a question, I answered, and then you said I'm wrong. I said that's irrelevant. Let's ignore that.
All right. Well, no. I think the only thing that we've been wrong about is whether or not photons decay like you say they do.
Well, I'm still looking it up.
Okay. Well, at any rate, I am going to step away. You can drop me a line if you discover the truth about photon decay.
Okay. Oh, so I think photons don't decay, but other elementary particles can decay into photons. So photons don't decay. Everything else decays into photons. All right. Is that it? Or the word decay? I mean, here's an image. Here's an image where an electron, or these are two, no, yeah, this is electron. Is this a positron? Yeah, I don't know. Electron and a positron, they decay, they convert into a photon, and then if the photon becomes the electron positron again. So I don't know if the words decay. I don't know why Brave didn't like the word decay. Electron scattering. So can a photon turn into other elementary particles? Anyway, that's irrelevant to the proposition. The proposition was, can the ether wave model explain Compton scattering? So yes, the answer is yes. Irrelevant, what I'm trying to say is particles cannot exist, but again, that's irrelevant. So, but omnivore always disappears during debates.
How does it explain Compton scattering?
How can, if you look at the image on the side chat, there's an image of, I'll copy it and paste it again, I guess, or maybe I'll reply to it. No, I can't. There's an image on the side chat that I pasted, that shows photons as waves in the Compton entry on Wikipedia. In Compton scattering, if you look at Compton scattering in Wikipedia, you see that the photons are waves. They show, here's the link. They show the photons as waves. So all I'm saying is you could view the photons as wave packets, meaning they are waves. They wave through the ether. You don't have to say ether. You can choose any other word you want. I don't care. The photons can be explained as waves in Compton scattering. That is actually the way Wikipedia shows shows the image. Again, in the side chat. So that's it. I don't know what else to say. I mean, it's really straightforward. Questions? So I don't know what else to say besides I don't know. I mean, that's it. It's really straightforward. There's nothing deeper than that. Does anyone have any questions about that? It's difficult to debate a person that disappears during a debate. So I win, I guess. I don't know what else to say. If my opponent chooses to disappear during a debate, that's it. I don't know what else to say. Not that it's important. I mean, the purpose of a debate is to figure out the truth, and I'm happy with my truth. Let's see, you're saying wave packets are not particles. Exactly. Exactly. They are
In the stern-gerlach experiment, it was your claim that that's classical physics and not quantum.
My proposition is that I can explain stern-gerlach completely using classical physics from start to end with without blinking. I made. Go ahead.
How would you do it if it has quantization of the angular momentum? Because that's not a classical effect.
Great question. Absolutely great question. So that's actually really, really simple. So look, you agree that an electron has a quantized mass, right? You're not surprised that an electron has quantized mass, right? Do you agree or not?
Classical physicists were.
Wait a minute. You just said that. How do you explain quantized angular momentum? So I'm just saying, well, you're asking about angular momentum. You're not asking about the mass. And now you're saying, yes, you're also saying that, how do I explain quantized electron mass?
I'm pretty sure you didn't follow along with the conversation that just happened, because now you're saying it happened in a way that it didn't happen.
I don't care. I mean, just let's just have a
You don't care?
conversation. I don't.
Okay, let's have a conversation. Okay.
Well, no, I'm just saying, let's have a conversation. You're asking great questions. I'd love to answer.
Let's have a conversation.
Excuse me? Your audio is really bad.
Let's have a conversation.
Great. Just that you're echoing. Your room is really echoey, so I'm having.
I can't do anything about that.
That's fine. I mean, you could get closer to your laptop. I'm assuming it's a laptop. You're using.
I'm actually getting audio from my headphones. So they are literally like on my mouth currently.
Oh my god! Oh yeah, it's horrible. So
maybe I can use my laptop audio.
No, it's good enough. It's good enough. if it's fine. You can try, during our conversation, you can try anything else. It's fine.
Yeah.
So let me end it. I'm
Um,
just trying to understand. So you said
yeah.
right. So I said I can explain completely classically the stern-gerlach experiment. No problem.
Yeah.
It's really very simple. And then you said, really? Can you explain the angular momentum or moment of inertia or magnetic moment, whatever?
Yeah.
And I said, well, sure, but let me just make sure about the, right? You said quantized angular momentum. And I'm asking, wait, before we go to quantized angular momentum, you agree that the electron in itself is quantized. So you agree that the electron exists, it has a mass, it has a charge, it has a location, some sort of a location. I'm not saying Heisenberg right now, but you agree, right? Right, but your only question in terms of the Stern-Gerlach experiment is the angular momentum, which is the only thing the Stern-Gerlach tried to deal with, as far as I understand. Am I right or
Yes.
wrong? Mm-hmm.
Yes, and my response to that was your question about the electrons was
Mm-hmm. I
because
don't
you said that no
speak.
one was surprised.
No, just speak
And
slower. Speak slower,
hold on,
Chris. No, you speak slower. I can
okay.
barely
Yes.
and louder. I can barely understand what you're saying. I'm missing words. That's all I'm saying.
All right.
Slower and
Let me
louder.
speak. I'm slower then.
Thank you.
So when you said that electrons are also quantized and no one is surprised by that, then I said, actually, who were surprised by that
Who?
were classical physicists, because in classical physics, electrons are not quantized. And then
Mm-hmm.
you went on some tangent trying to recap the previous conversation in a way that in no way accurately recap the conversation. So are we now at a point of continuing it more reasonably, since I now corrected you that you were wrong, and this is what happened?
No, I'm asking you. I'm not asking what
Yes.
happened. I'm asking, look, we are now, me and you together, right? We're having a conversation. We are trying to explain Stern-Gerlach in a classical way. Maybe I'll be able to do it. Maybe I'll fail. I feel that I've explained it to myself well enough that I'm able to explain it now to you. But maybe you'll find
Right.
issues in my explanations and I'll retract, and it's fine. I mean, this is why we're talking to, I'm interested, right? So I'm just asking you in this conversation. I mean, do you agree that electrons exist? There are such creatures called electrons. Do you agree that they are? Go ahead.
Yes,
Okay.
I agree
Mm-hmm.
that electrons do exist.
Okay.
Now, what I would be willing or very excited to hear is your explanation of the stern-gerlach in a way where you explain it classically and do not refer to electrons as having quantized states, because they did not have that in a classical mechanics.
Wait. Forget about. I don't know what it means. They did not have it in. I don't know what that means. Electrons did not have it in classical. I don't know what that means. I honestly don't know what that means. Like if no. So look, all I'm saying is I'm going to try and explain Stern-Gerlach classically. and I need, we need to start from somewhere. So, like, my assumption is that we're starting from the fact that an electron is, we certainly can explain the electron classically, right? Until Stern-Gerlach, we were able to, right? What's his name? Milken, right? Milken measured the mass of the electron, the charge of the electron, and he found that it's quantized. There is a quantity, and this was classical. Unless, look, it's a question of definition. Unless you would say that, like, the electron is not in the classical realm. So we need to, like, figure out definitions. My point is, I can explain Stern-Gerlach classically, but I need you to grant me that the electrons can be explained. The very fact that Milken got the mass of the electron, and we've seen electron beams in cathode ray tubes. We have enough data that electrons exist. They have mass. They have a charge. And that we can explain classically, right? We know what a mass right. You agree that mass is a classical metric. Charge is a classical metric, right? I mean, I need to know where we're starting from. Like, what's the question? Because you said, I just don't understand the angular momentum or the magnetic moment. I said, okay, let me just make sure we're starting from the same ground truth. Let's ground our discussion so I can build on it. I'm just trying to ground it. So you're saying an electron is not classical. So, all right, then we need to define our terminology. Are you following? Like, I'm just saying, I've listened to people talk about Stern-Gerlach, that it is the beginning of the end of physics, that the universe is conspiring to hide the magnetic moment, and there's only up and down and qubits and Dirac notation, and to me, that's nonsense. I can give you a perfectly valid classical explanation of the Stern-Gerlach, why they got the spreading and nothing in between, right? We got some electrons were up, some were down, none were in the middle. That was the big question. Why isn't there a spread of electrons? They claimed classically we should have received a spread. And I would say, no, classically, I don't expect a spread. If you want me to explain why I can reproduce. If you give me tiny magnets, I'll reproduce Stern-Gerlach with no spread. How about that? I can do that if you want. That's what I'm saying. So tell me what you want me to do. Like, this is just a conversation. I'm not here to hurt anybody's feelings. I'm just letting you know.
Yeah.
Like, electron spin bothered me for years. And now I think I figured it out. I can reproduce any, like, at least the Stern-Gerlach, at least that I can easily reproduce. I can build a model of the silver atom, and we'll agree on what a silver atom is. And once you'll agree that we can reproduce Stern-Gerlach, and there's no spread. There's only, it's the angular momentum is, as you say, it's quantized, which to me is classical. Just like the mass of the electron is quantized, and just like the charge of the electron is quantized. And I don't think I need more than just that. Given the mass and the charge of the electron, I can derive from these. Let's call these the first principles. Maybe I'll add a few more first principles that we'll both agree on, classical principles, and I'll be able to derive from these first principles that we'll agree on the Stern-Gerlach result, that some electrons will go up, some will go down, and none will be in the middle. And you don't need any, like, to me, what is complete and utter literal nonsense about the universe conspiring. And I don't know what else people came up with. Like, people came up with entire universities and university degrees. And I think quantum computing comes out of this nonsense. It could easily be explained. And actually, I made a video yesterday. I made a long, I think very long, 4-hour video in which I was listening to people, big names, doctors and academia and academics, and good channels, and with each one getting lost in the Stern-Gerlach experiment, I was able to catch them all basically at the same mistake that led them down the path to confuse themselves. And I don't know, and then I listened to historical notes from Bohr and
Hey,
Born.
bud. Hey, bud. Could you just consolidate? I just joined the thing. Could you just give me a synopsis, quick rundown of what's going on, man?
Yes. So it's actually a proposition. It's a very interesting proposition, a very new proposition about that I can explain the Stern-Gerlach experiment from using classical mechanics only. Here it is in the side chat. So debate: can we explain the Stern-Gerlach experiment using classical mechanics only? I'll rephrase it. We can, or I can, or
Yeah, you lost me at Stern, mate.
Hold on, let me just rephrase it, then I'll help you. I can explain the Stern-Gerlach experiment using classical mechanics only. So you want to ask questions like what? You don't know what the Stern-Gerlach experiment is? What's your question?
I don't. I could have looked it up. I just I'm not on Google quite yet.
I would say that Stern-Gerlach is the beginning of what we call today quantum computing, and I think it's nonsense, and I can basically debate it and prove my point. At the end of the day, quantum computing is complete and utter nonsense.
But if everything's made out of ones and zeros, then it's very easy to count them. Wouldn't you agree? We stick them in a cube, stick them in something that doesn't require any magic numbers, just simples, sides times side times side, whatever. Quantified. I guess you can quantify anything. I guess if you stick in a box.
I don't understand what you're saying. Look, we have an experiment. It's called Stern-Gerlach. Everyone seems to be confused about it, and I can explain it. And I think no one has been yet able to explain it. I would say, including Bohr, which is weird because it's all based on his theory. I don't know why he didn't. Go ahead.
Well, what does Stern in? Is there a translation, which I'm sure there is, for what stern-gerlach means? And you might say, though, there's no correspondence, but sometimes there is. Is there any meaning to the name against the principle? Whatever.
The name of Stern and Gerlach. Stern and Gerlach are just two eminent physicists, experimentalists.
Fine. That's sorry. I'm with you now. I thought it was one person. Sorry. Thank you.
Okay. So anyway, they conducted an experiment to show that Bohr's model of the electron's orbit around the nucleus of an atom is nonsense. Literally, they called it Bohr's nonsense, I think. That's what they used to call it when they talked about their experiment. They wanted to prove Bohr's theory of basically the electron as a wave around the nucleus of an atom is nonsense. They, I guess they felt, I'm assuming, the alternative, and that's what you see. Everyone on YouTube, they're all confused, just the same as Stern and Gerlach were initially, in the middle, at the end, and since then, everyone apparently has become just as confused about this theory, Bohr's theory. So everyone from the animations, everyone thinks the electron is a particle that orbits the nucleus of an atom. That's what everyone that teaches the stern-gerlach experiment, that's how they all animate it. They use animation. Well, obviously, we don't have other photos of what the electron is literally doing around the nucleus. So everyone, when they do the animation or they do the calculations or they talk about it or explain it, at one point or another, they're going to say it's a particle orbiting the nucleus. And that's basically exactly what Bohr came to say it's not. So if you think it's a particle orbiting the nucleus, of course you're not going to understand Bohr's model, and you're not going to understand the stern-gerlach result. But if you do
This has been quite interesting for me.
Thank you.
Because I remember at least 10 minutes ago or something, we were in a part of conversation where you were asking me questions in order to establish common ground so that we can build this argument.
Sure.
But then you never waited for me to actually give any answers, and you went on a long diatribe. And then I decided, since this guy is so willing to go on without actually listening to the answers, so this is not actually a conversation, this is a diatribe. Let me see how long he will go without even realizing that he was supposed to ask me questions, but then he never waited to get the answers. And it was quite long that you went on a monologue while not even waiting for the answers to the questions that you were claiming that you were asking me.
Look, I don't want to get into a fight, so you can always you can.
Yeah, sure.
Look, you can always interrupt me. That's
So let's just have a conversation, and if you have questions to ask that you need to ask in order to make your case about the stern-gerlach, just ask them. And then wait for me to give the answer. So what questions would you want to ask about the stern-gerlach?
Oh my god, you're funny. Anyway, what do you mean? So I asked you for common grounds. Can we agree that electrons exist?
Yes, even in classical mechanics, they exist.
Great.
Any other questions?
I wouldn't. Okay, I would just. Okay, fine. I would just say we can explain electrons existing using classical mechanics. That's how I would say it. But it's fine. So, and you agree that electrons have. We can explain electrons having quantized mass using classical mechanics, right?
I would need to see your argument for that. So that if we want to make that a common ground, you're gonna have to make that case.
Wait, you think different electrons have different masses?
I didn't say anything about masses, so can we stick to that topic? The topic was, you asked me if I agree that electrons can have quantized states in classical mechanics.
I
said that if we want to have that as a common ground, you need to make that case and you need to prove it. I said, I didn't say anything about masses, so don't go on a tangent about masses and don't put words into my mouth. I never mentioned.
I'm a free person.
Yeah,
I'm a free person. I'll do whatever I want.
Yes,
so if you don't want to,
yes,
if you don't want to have a conversation, it's okay. It's fine. But
I do want to have a conversation. It's just when you say something that isn't accurate, I'm also a free person and I will call you out, whether it's by mistake or by some other thing. I didn't mention anything about masses, so I'm not sure why you jumped to masses.
I brought up mass.
I can remake the point. So my point was simply, if you want to ask me if I agree that classical mechanics also has electrons with a quantized state, then I'm going to say, well, if you want that to be the common ground, you will have to make that case. In none of that, no word in that sentence had anything to do with mass. So you don't need to talk about mass at this
Um,
How would you answer to that without using the word mass at all?
I brought up mass.
Yes, you did.
Yeah, I need to know what are. I need mass in order to derive the magnetic moment, the quantized magnetic moment of the electron actually depends on a quantized mass of the electron. So I need to know
Mhm.
if we can start from a common ground that electrons have quantized mass. Yes or no?
Mhm. Well, if you want that to be the common ground, you're going to have to make a case for it. Can you make a case for it?
I'd rather not divert the topic because I
Yes, but
let's
we're just going to have to.
let's just agree.
See.
But you agree that a baseball can have quantized mass, right?
No,
Okay.
you're constantly. Let me try to make a case of common ground here. You're constantly asking me questions of, will you not definitely agree that this and this and these things were quantized in classical mechanics? And even if that drives us away more and more and more away from the original point, I will always have to make the case that no, you will have to make the argument for it. Because quantization of energy levels, quantization of these different things is the key mechanic that differentiates classical mechanics from quantum mechanics. So you cannot get me to agree to any single one of those without having to make a case for it. So it's sad for you that you keep going on this spiraling cascade down further and further, where you have to ask me more and more questions about, well, can you agree that this is quantized? Can you agree that this is quantized? No, I will not agree that anything of those things is quantized. Those all come in a package that you need to now prove. If your argument for the quantization, if your argument for what we are talking about relies on all these different things, then those are all adding to the package that you need to prove. So I'm just asking you to all now make the common ground that you are seeking and prove all of them.
So just a quick one. So these electrons, do they change in size? Does its density change? Because if it does, then it's hard to quantify it. You know what I'm saying? Like a bit like air bubbles or water bubbles, like when they're heated and cool down, blah blah. If you do that with electrons, would electrons not do the same thing? They would get bigger or smaller, but their mass would be the same, except their volumes change, so their densities changed.
So that's what I'm trying to get my esteemed friend to agree with me on as a common ground, namely that electrons all come in the same mass. That's
Yes, but you know, with some people, you have to identify they might just want short sentences with factual words that consolidate 5 minutes of talking.
Good. So what is your case then for arguing that in classical mechanics, electrons have quantized mass? If you were to have to, let's just stick to that topic now and see what your case is for that.
I'm confused. So I said my proposition is I can explain the stern-gerlach experiment using classical mechanics only. Now, then you said you said, really, how do you explain the quantized magnetic moment? Right? You didn't ask me any other question. So I just
Yes.
I just wanted to make sure that we agree on everything else except for the quantized magnetic moment. I can derive.
Yes.
So I said I can derive the quantized magnetic moment if you grant me a quantized mass and a quantized charge for the electron, and maybe I'll
Yes.
need other ground truths for you to grant me.
Yes.
So would you grant me for this discussion that electrons all have a certain mass, like a quantity of mass? They all have a quantized mass. I mean, would you grant it so that I can explain stern-gerlach's magnetic moment? Right? Everyone is only confused about the stern-gerlach magnetic moment. No one is confused about the stern-gerlach mass or the stern-gerlach charge of the electron.
Yeah. I have no reason to grant you any of that, because I'm just asking a question, and whatever building blocks you need to even start to make your case for the original question, they are now yours to build. So if this all takes you down on a cascading collapse of, well, to actually prove my case for the stern-gerlach, I need to prove this first, and then I need to prove this first. Well, that's a problem for you.
Let's work.
But I'm not here.
That's fine.
I'm not here to grant you things.
That's fine.
For
That's fine.
classical mechanics that were not there in classical mechanics, as far as I understand. And if they were in classical mechanics, then the case is for you to prove so.
That's fine. Look, we can do this backwards. So let me assume certain ground truths, and let me derive from these ground truths the quantized magnetic moment, and then we can go backwards and we can discuss quantized mass and quantized charge and any other truths that I needed in order to explain the quantized magnetic moment. How about that?
Sure.
All right. So I'm going to temporarily assume that all electrons have the same mass and the same charge. All right. The next, so I would say that if I would magnify two silver atoms, you agree or disagree that they are indistinguishable, except for their orientation, their magnetic moment. Right? We all agree that silver atoms have a magnetic. Well, do you agree? All silver atoms have a magnetic moment, right? You agree with that?
I do not really know. You keep using terminology that I didn't talk about.
Sure.
Let me clarify something.
Sure. And as I said, you can grant it temporarily, and then we can roll back. I mean, we can go back and we can discuss each building block. I'd rather not build right now, everything from first principles. I'd rather go to the last step, explain stern-gerlach, annihilate quantum computing and the rest of the nonsensical modern physics nonsense about woo-woo cats and dogs being alive and dead simultaneously, and then we can say, okay, we built it on certain assumptions. Let's now discuss these assumptions and see that indeed they are as we said. Yeah. If they're not, we'll roll everything.
Yeah.
Go ahead.
Yeah, maybe this is what we should do. Maybe we just don't talk about silver. Don't talk about, maybe silver, because it's kind of essential for the experiment, isn't it? But let's not even talk about electrons or their quantity. Let's not talk about any of that. Let's just focus on, is under classical mechanics, can you have quantization of angular momentum, yes or no?
I mean, given, so I would say yes.
How would you explain that?
I mean, if right, so the magnetic moment, or you want to talk about? I didn't notice. You talked about angular momentum or magnetic moment. Which one do you want to discuss, or you don't care?
Angular momentum.
Angular momentum. Okay. So the angular momentum. So you want me to show you that a silver atom can have angular momentum without discussing the electron?
No, I don't need you to show me that a silver atom can have angular momentum. I need you to show that the angular momentum can be quantized to
But
classical
but
mechanics.
okay,
The
but
quantization is the problem.
yes.
Something having or not having angular momentum isn't a problem.
Yes, but I need to discuss the electron. It depends. I mean, it all depends on the electron. I
Yeah.
need
So make your argument.
Okay, so the electron. So it's the electron that has the angular momentum.
Yeah.
And the electron is waving, as Bohr explained. The electron is waving around the nucleus. And it has a certain mass and a certain charge. So it's basically,
Yeah.
so it has current, but okay, we just need the mass. You just want the angular momentum. But there is a certain velocity. This wave has a velocity. And this velocity is the kinetic energy of the wave. And this kinetic energy was given to the electron, or the electron collapsed into this minimal configuration. So the electron, as it is orbiting as per Bohr's model, so the electron is orbiting the nucleus, and it must orbit at n times lambda. Lambda is per de Broglie. So an integer multiple of lambda, that's the only length allowed that an electron can occupy such an orbit. So there are certain configurations because the electron is a wave. Because the electron is a wave, so it cannot wave in half wavelengths. It has to wave in complete waves. That is classical. So this gives us certain configurations or states.
Hold on.
Yes. You said
I
hold
don't
on.
think that makes sense. I don't think what you made. I don't think that sentence that you said just now makes any sense, because you said that waves cannot be at certain wavelengths, or waves can only be at certain wavelengths because you need complete waves. That's a complete misunderstanding what a wavelength even is.
Look,
like, of course, you will have to have complete waves, but you can change the wavelength and the frequency without breaking things up to half waves or anything like that. So when you talk about these things and then you say something like, but then you wouldn't have complete waves, that's either you're misunderstanding what wavelength even means, or you're trying to hide something
no,
by
no.
making vague statements that make no sense.
No, you're asking good questions. Look, so de Broglie offered us a wavelength for the electron, that the electron only has a certain wavelength, if I'm not mistaken, right? Does the electron have only one wavelength, or can it change its wavelength? What does de Broglie say?
It can change its wavelength.
An
It
electron
certainly would have
can have
several
different wavelengths?
Yes.
In de Broglie?
Well, de Broglie, I don't know if de Broglie can have different wavelengths, but electrons can be effectively at arbitrary energy.
No, energy is
Well,
different.
it's correlated to the wavelength.
Let me check. Can electrons...
By the way, we're still talking about electrons, and at some point we need to move to the silver atoms that are really more key to this.
Let me check. You can go. I need to do a detour. Let me check. Can electrons have different...
I'm glad, by the way, that this is more of a chill conversation. I just realized that I shouldn't be speaking too loudly. And if this was your typical shouty conversation, I would just have to say that, okay, I'm just gonna not be able to do this because it's too loud. Because we're having a respectable conversation, I can still talk.
Yeah, it's a good conversation. No, you... I need to go back to my lecture. The lecture... there's good lectures on electron wavelengths. Let me look it up. I mean, we know that electrons can only occupy certain orbitals, certain shells, certain orbits, according to Bohr, right?
Bound to an atom, sure.
What causes that? And everybody...
But your question was about electrons in general, not about bound electrons in an atom. Your question was about, you didn't specify. If you had said in atoms, I would have said there are certain constraints, yes. However, free electrons, no.
Okay, but an electron, like the outer shell, the outer valence electron in a silver atom, so it's confined there. It has a certain configuration. It can only be in that specific orbit, which is determined by n times lambda. The energy is given. I mean, that is what makes it that orbital, right? Orbitals have configurations.
Not necessarily, but the initial design of orbitals wasn't actually quantized. What you're talking about is the fact that the electron orbitals are quantized. Yes.
But what causes these configurations? Like you agree that all silver atoms look the same, except for their angular momentum orientation, at least of the final, of the last of the outer valence electron. So all silver atoms look the same. You couldn't distinguish one from the other if I point them all, let's say, up, right? And you can't touch the electron in the outer valence, without giving it a quantum of energy, only a very specific quantum of energy, to bring it up, let's say one orbital up, and then it would collapse naturally back down to the original. So at the end of the day, basically all silver atoms are identical. The electrons are orbiting with a known velocity, namely they're all electrons in the outer valence shell of all silver atoms have the same velocity, the same kinetic energy, the same energy. That's, if we assume that, if you grant me that, then immediately, of course, you get quantized angular momentum. So
how does that lead to
what?
a quantized angular momentum?
Wait, what?
How does that lead to a quantized angular momentum?
I mean, it's a mass times velocity, MVR. That's it. If you gave me m, if you grant me a constant mass of electron, if you grant me r, n times lambda, if you grant mv, and the v, right? The v is the kinetic energy. So grant me a quantized energy. Grant me r, a quantized r, right? Right, again, if I show you two silver atoms, you would not be able to tell them apart except for the orientation, except for the angular momentum. And the angular momentum, the direction is not quantized. The direction, it could point anywhere. It's free. It's free to point anywhere. But the amount, mvr, is quantized. M is quantized. V, that's the kinetic energy. The energy is quantized, and the R is quantized. Once we agree that a silver atom, all silver atoms look the same. If we magnify a silver atom to the room size, and you look at two silver atoms, you would not be able to tell them apart except for the orientation of the angular momentum of the last valence electron. So let's orient them all up, perfectly up. Now if you grant me that you cannot tell them apart, then their angular momentum is quantized. MVR is a quantity. And that's stern-gerlach. You don't need anything besides that. Now, if you want to work everything backwards, I'll be glad to. But if you grant me a configuration, just grant me that all silver atoms look the same. We're done. Now we can examine, why do all silver atoms look the same? Well, it's because all the valences look the same. We can work it backwards, but that's it. Stern-gerlach is really nothing, but it's completely classical. There's nothing surprising about it to me.
That's really interesting.
Thank you.
What is really interesting about that is you said grant me quantized this, grant me quantized that, grant me quantized this. When you say quantized, you are talking about quantum mechanics, aren't you? We're no longer in classical, are we? So again,
no,
that already completely, it all tumbles down from there.
Yes, we can work backwards. I don't have a problem. So now, but you agree that if you granted me everything I asked for, now you agree that Stern-gerlach, based on everything you granted me, you agree Stern-gerlach becomes completely classical. You have to let me know if that's how you feel. I'll gladly work backwards to every first principle you could ever want. And maybe I'm wrong. Look, I'm not here to claim I'm right. I'm just here. I'm here to be cross-examined.
Yeah, basically what it looks like to me is, if I grant you everything else, so basically if I grant you classical mechanics and allow you to call that, if I grant you quantum mechanics and then allow you to call that classical mechanics, then I agree within the quantum mechanics that I've now granted you, that we, for the sake of this conversation, we're not now just going to call classical mechanics. In that system, yes, you would be able to explain it using classical mechanics, but it's actually just quantum mechanics. Okay. Because I granted you quantum mechanics.
Okay. So
and then we just decided to call it classical for the sake of the argument that you're making.
Okay. Let's forget about quantum mechanics. Let's build a room-size silver atom. A room-size silver atom. Let's build two of them. Do you agree? Wait, you're here. Do you agree that we cannot tell them apart except for the orientation of the angular momentum, right? Yes or no?
No. I wouldn't be able to say either yes or no because I don't know enough, but I will allow you to continue.
I mean,
I won't make a point about my own ignorance here.
No, I mean, ask me questions about how to build a room-sized silver atom. Let's discuss it. I mean, it should be really straightforward. We both know enough about it, or we know enough about, we want to build a model, a classroom model, a computer simulation of a silver atom. It should. I mean, a silver atom should be straightforward. There's nothing confusing about it. So help me help you build a model of a silver atom. Do you want to?
Yeah.
But do you agree that we could build it? I mean, if you feel uncomfortable, then you can ask me
Yeah,
questions.
we could build it. We could build it. Yeah, sure.
Okay, and now once we've built two of them, you agree we cannot distinguish between any two, except for the orientation of their angular momentum, right?
I'm not sure if I can grant you that, but that's because I don't really know too much in detail about this. For the sake of the argument, I can say, yeah, sure.
Look, I mean, you can always retract. I'm not here to catch you on
I don't need to retract.
Okay,
Because we're not getting anywhere if I retract.
It's fine. I mean, you can always say whatever you want. I'm not here to catch you on anything. I'm here, honest to goodness. I feel I have a good explanation, a good, simple, classical explanation to the stern-gerlach experiment. I think I feel yeah.
I think we're in good ground. You do make a good argument for stern-gerlach being able to explain it classically, if we grant that quantum mechanics is actually classical mechanics.
No. I'm not doing that. I'm not assuming. I just said let's forget about classical mechanics. Let's forget about quantum mechanics. Let's start from classical mechanics. So we're building two silver atoms, two room-size silver atoms. Again, I'll ask you: do you agree that they are identical except for different orientation of angular?
Let's say they are identical. Sure.
What? Yes. Okay. Now, what makes them different? Let's talk about let's talk about the differences. The difference is that one of them has the electron orbiting the nucleus, right, in one direction. Let's say they're not oriented in the same direction. So one of them, let's say, is pointing up, and one of them is pointing down. The one pointing up, the electron is running around. It's a wave. The electron is a wave, and it's waving around using the right-hand rule. Right? It's waving around using the right-hand rule around the nucleus. You could, right? And the one oriented down using again the right-hand rule or the left hand. I don't remember. Yeah, this is just angular momentum. So angular using the right-hand rule, we said pointing down, so we know how it's waving around. My point is, it's a wave, and it's waving around. This is not something we see. You could, I mean, it's different. It's a little difficult to imagine what it means to wave around, but you could imagine that the Earth has an ocean. Let's say the Earth was a water world, a water planet. And you can imagine a single wave going around, waving around the planet. Let's say it's a water world, pure water, a water planet, nothing but water. And you can imagine a water wave just going around and around and around and around. Now, the electron is not a pure water world. It's a water tube going around a planet. But it's a it's a wave. Anyway, if we need to discuss, it's a wave, probably compression, decompression. It's similar, I would say, to a sound wave. It's a wave, like I believe in the ether, so it's a wave of ether. It's very specific wave. It's not it's whatever. It's a wave, but it's waving around the nucleus, and it's a wave that has mass. We're not used to usually that waves have mass. So, and it has a velocity. It has where this wave has a velocity and has a mass. Therefore, this wave has angular momentum. Right?
Yeah.
And the way it works is this thing can only wave in multiples of the wavelength, right? If you imagine a wave going around and around, but it can only wave in full wavelengths. So it cannot, because if it doesn't wave in full wavelengths, then you have a discontinuity, and we don't have discontinuity in nature. So in order to have a continuity, in order to make sense, and just in order to make sense, so it can only occupy, right, and therefore it can only occupy certain orbits.
What do you mean by full wavelengths? Can you define that?
So if you imagine, right, let's prove by contradiction. So if you're saying that an electron does not need a full wavelength, only it doesn't need a full wavelength, then you have a discontinuity, right? Because let's say half a wavelength. Let's say the electron is waving around the nucleus. Let me draw this for you. Do you want me to open up a whiteboard and I'll draw what I mean? Is that okay? Are you fine with that? All right. So let's go to whiteboard. Let me create a new, and this will be oops, what just happened? Let's try this again. This is the stern-gerlach. Let me, okay, zoom away. I don't see you. I don't see, oh, there you are. Okay, good.
I see a penis. Is that the stern-gerlach?
No. You're in the wrong. You have to come to stern-gerlach. Come to the stern-gerlach.
How do I come to the stern? I just joined the whiteboard.
No, but yeah, you can choose different canvases. Each one has a name. So I created the newest the newest canvas is the stern-gerlach. Stern-gerlach.
Hold on, I'm still at the pencil lick.
So
all right. Yeah, I'm here.
Wonderful. So what I mean is, let's say this is the nucleus, and this is the orbit about which it is waving. So let's say this is a wave, and I'm describing compression, decompression, and it must meet perfectly. This meets perfectly. You cannot have a discontinuity. This is, for example, there's 3 crests. So I was able to fit 3 waves, 3 wavelengths. So this is n equals 3. So
why would it have to have that kind of characteristic?
Because if it's
I'm just thinking about
mm-hmm.
I'm just thinking about in terms of classical mechanics. Let's say actually your analogy of, let's imagine a planet and a wave going around it. That's actually quite brilliant, but I'm not sure if a wave made of actual water going around a planet would have to have this property of having of being like this.
Look, you're gonna have a discontinuity. For example, let's draw an example with a discontinuity, and we'll see that it just doesn't make any sense. So here's another wave, and let's say this one. You see the problem? This one. What is that? I don't know. Because this represents pressure. We're representing pressure and compression, decompression. right? This is like a sound wave. You could do it as a water wave, but it wouldn't make any sense for this to be a water wave. Like it could be. I don't know.
Can I ask?
Yes, go ahead.
Can I ask a clearing question?
Sure.
Are you assuming ether in this example, or are you assuming no ether?
Yeah, I'm assuming we're waving in the ether. I don't know how else. I don't know any other definition.
So then, what would an electron be in your ether theory?
It's a wave, some sort of a wave. You can imagine it like a sound wave in water. You can imagine a sound wave in water, but this one is
sure, but
Mhm.
but then you're saying that the electron is actually made out of ether, right? It's just a wave in the ether.
Everything is a wave in the ether, according to my ether.
So then nothing exists except ether.
I don't know what it means to exist. A wave exists. So
no, but hold on. A tidal wave is water, right?
Yes.
So then an electron is ether.
Well, an electron is a wave in the ether.
Yeah, just like a tidal wave is wave of water.
Yes.
Yep. So then electrons don't exist. It's just ether.
Well, then would you say a tidal wave doesn't exist?
No, the water exists.
But the tidal wave, does it exist?
No, that's made out of water.
But would you say that a tidal wave came in and destroyed, I don't know, the beach?
Oh, it's not a thing. It's water.
Everybody agrees that it's water, but there is a phenomenon, right? We humans, we notice phenomenon and we name phenomenon.
Yeah, it's a phenomenon.
You could say there's
yes.
you could say there's no water because it's just H2O. I don't know what water is. I only know H2O. You could say whatever you want.
No,
you could say whatever you want. We're having a conversation.
Sure.
We're using words to share ideas. So
sure. Okay. So in classical mechanics, is there ether?
I'm not saying yes or no. I'm using my proposition is I can use classical mechanics, and the ether model is certainly classical. Yes, the ether model is a fluid, just fluid mechanics. That's all it is.
But in classical mechanics, you have particles, right?
Well, the ether model is a fluid, and the fluid model ultimately is probably particles. Yes.
But you just said that there's only ether. Fluid, there's no particles.
Correct. The particles of the ether. The ether is a fluid that is defined, as far as we know, is defined to be composed of ether particles, whatever they are.
Sure. So then electron. Well, I'm sorry. Just continue. I was just wondering because I think you're talking about two different things. Because you're now having a wave, but it's not an electron in any sense that the classical mechanics talks about electron or quantum mechanics.
You don't have. I don't need the word electron, and I don't need any words. I mean, all I'm saying is, I mean, we have, let's say, the laws, right? We have Newton's laws. Basically, we can derive this entire discussion, right? This is just wave mechanics. I'm just assuming wave mechanics here. Wave mechanics or fluid dynamics or fluid mechanics and Coulomb's law. Basically, we have a wave.
But weren't you talking about the stern-gerlach experiment?
Yes, we're describing. I'm explaining. My proposition is that I'm able to explain stern-gerlach using classical mechanics. Yes.
But classical mechanics, you don't mean the classical mechanics that assumes that there's particles and no ether. You're talking about some other classical mechanics.
I don't understand what you mean. I'm using classical mechanics. What don't you understand? Why don't you ask me a question? I'll try to explain.
Sure. Yeah. What classical mechanics do you mean?
Ask me a question about the model. I'm explaining my electron model. Why don't you, using ether, waves in ether, using classical mechanics, just ask me questions. What don't you understand?
Yeah. What do you mean with classical mechanics?
Okay, ask me questions in fluid dynamics. Ask me questions.
Oh,
Yes.
no. You
Classical.
said that you can
Okay, classical
explain the stern-gerlach using classical mechanics.
fluid.
What do you mean with classical mechanics?
Fluid dynamics, for example.
Fluid time. So you're explaining stern-gerlach not in quantum mechanics but fluid dynamics.
Correct. Using classical
Okay, sure.
mechanics.
So not classical mechanics. That's good.
Well, fluid mechanics is classical mechanics, right? It doesn't. It doesn't matter. It doesn't matter. Look, it doesn't matter. Wait.
Okay, sure. Sure. You're saying that electrons are fluid mechanics.
I'm saying that I can explain stern-gerlach using fluid mechanics and classical mechanics.
Okay. Sure.
Do you have any
I mean, I can say it's hydrodynamics. I can use hydrodynamics to explain how light works because it's wave. Right?
Look, it doesn't matter. We're talking about waves. That's all we're talking about. It's a wave. We're talking about a wave that is made out of electrons.
Ether.
Yeah, of course, but it's a wave in the ether. But we're discussing now. Okay.
I actually.
Yeah, I muted that guy. Like, okay, let's get back to our discussion.
Damn.
Lahoy.
You can call me Lauri.
Wait. Mr. Slate, did you mute somebody?
I muted somebody that kept laughing at me. I did not enjoy that.
That spelling of my name is a total joke.
Like every answer I gave him, he laughed at. So I didn't appreciate that. Like you, if you have questions,
I actually appreciate it. Yeah.
Right. Yeah. So I'm here to have. The most important thing is to enjoy my time. So if you're gonna laugh at me, then I will mute you.
Yep.
Mr. Lahoyer.
It's just Lauri.
Lowry? Lowry?
Lauri, yes.
Lowry.
Yeah. That's quite good.
Lowry.
I actually was thinking, I don't agree that you're actually explaining this in classical mechanics. Because while you guys were going on a tangent, that allowed me to think about the discontinuity that we see there. So I kind of appreciated the tangent. We actually do see this kind of discontinuity right here. I can mark it with the red ball. We do see this in real life all the time with waves. What happens, for example, when a tsunami wave meets the shore? That's this right here. It's a crashing wave.
Right.
So it happens in real life all the time. If you think about waves meeting a shore.
Yes. So let me just add.
You will have waves at this point.
Yes.
All the time.
Yeah. So I'm assuming, or you can grant me, laminar flow. All flow in the ether fluid is laminar. There's no turbulence in my ether model.
Or it's a standing wave.
No, I didn't say it's a standing wave. This is not a standing wave. Standing wave. What?
Yeah. Typically, people talk about it in terms of standing waves, but if that's not what you're going with, sure. No, I'm not going to strawman your argument and put words into your mouth. So go ahead.
No, it's not a standing wave. A standing wave, you need two opposing waves to create a standing wave. This is just a wave. It's just waving around. It has a velocity. It's waving around. This point, if you put a person, and he's going to surf, he's going to move around. He's going to have a velocity. In a standing wave, this has to just move up and down. That's not this problem. This is not a standing wave. An electron is not a standing wave. An electron is a wave, period. So,
sure.
So you, right? You can just grant me that we don't allow discontinuities in the ether, right? We can always look. We're just defining things, or we're just we're just assuming certain building blocks. And
sure, but then you're not anymore talking about fluid dynamics. So
why
what
not?
classical system are we talking in? If it's not fluid
Laminar?
dynamics?
No, this is Newtonian fluid. I think in Newtonian fluid, whatever. This is. I'm just not allowing. This is laminar flow. Oh, there's no turbulences. That's all. It's that's all I'm assuming. We can laminar flow is it's standard assumptions in fluid mechanics. No turbulences. We're not assuming any. We're assuming no turbulences. We don't allow turbulences, and we don't allow.
Mr. Slave, you're gonna have to unmute him just because, like, he's talking right now.
No,
It's
I
gonna cause
can't.
audio chaos.
I
It's
can't. He's laughing at me. I'm like I.
okay. He's laughing at you, but so what? You just have to
No, I'm
unmute him.
not. No, I don't want to waste my time. No. Then I'll leave. It's fine.
Okay.
I'm not, I usually don't mute anyone, but he was being extremely obnoxious, and I'm having a good discussion with Mr.
How about
La. Jesus. Lowry. Mr. Lowry.
Are you making me laugh?
Who? Lowry? I made you laugh? I'm having
I think
a
you made
I'm having a very good.
We're all gonna be laughing if we keep going.
I'll mute anyone who laughs at me. So at the end, if I have to leave, I'll just leave. It's fine. I'm not. Look, I don't want to waste my time because usually I don't have a productive discussion, and then I don't mind making good content that my listeners like. But Mr. Lowry, I appreciate his time, and I think we're having a very productive discussion. So I'll mute anyone who's going to annoy me too much. Mr. Lowry, let's just make assumptions.
That's what I was
right?
about to say.
Okay. Who's the? Oh, he's doing that.
Yeah, it may have been me.
Anyway, so we don't allow. We're assuming no discontinuities. This does not exist in my ether model, and this is basically Bohr's assumption. And this just gives. This is the reason behind Bohr. I mean, why did Bohr come up with his integer multiple of lambda? This is the reason. I mean, this is how it works. Like when you try and build this model, this is the Bohr's model. Mr. Lowry, do you want to continue? Mr. Lowry?
You were saying that this is Bohr's model like this. What's going on here?
Yeah, obviously this is Bohr's model. I'm using Bohr's model.
It looks like a mess, to be honest.
It looks like what?
Like a mess.
Whoever laughs at Mr. Slave, I'm gonna ban you.
It looks like a mess? What do you mean it looks like a mess? I mean, people are drawing all over it, so it looks like a mess, but I'm just saying no discontinuities, and like I'm following Bohr's assumptions, Bohr's rules, and I'm explaining it within the ether model, and I'm giving the rationale. So, Mr. Lowry, do you have any questions?
No, at the moment.
Okay. Anyway, so given, I mean, the point is that so if we have two silver atoms, right? Basically, they, right? Let's say this is the angular momentum of one. This is the angular momentum of the other one. So the distinguishing feature is basically that there is an electron orbiting in a wave, and there is an electron orbiting in a wave here. And the orbit, we have the mass of the electron, the velocity of the wave, and the radius, and the radius. And because we're assuming multiples of integers of lambda, and let's assume they all have the same lambda and the same frequency. We'll come back to that. And the same energy, at least the top valence electron. Anyway, this is L. This is equal to L. So if we're assuming a quantized m of an electron and a quantized velocity because of energy and a quantized r because of lambda and frequency, so we have some quantized angular moment, angular momentum, right? Do you agree so far? We'll come back to figure these out. We might be wrong about any one of these assumptions about the configuration, these configurations, the frequency, the lambda.
Yep. Everything.
Mr. Lowry?
I may have lost the picture.
I'm at the bottom. I'm at the bottom. You can see my.
We are definitely at the bottom.
Okay.
Yeah. I shrunk your model to a small dot, and then I tried to confuse it by drawing more little red dots, and now I may have lost it.
You've lost what?
I lost the picture that you drew.
Okay. Look, all I'm saying is MVR. Right? You agree that the angular momentum is MVR. I'll type it. You agree that L equals MVR, right? The angular momentum is MVR of the electron, right? That's classical, right? There's nothing. I'm not. Yes? No?
Oh, there's an undo here.
Mr. Lowry?
Yeah, hold on. I'm trying to solve issues.
No, don't worry about it. I don't need to draw anymore. I mean, we drew enough. I want to. I want to finish the conversation. Come on.
Yeah.
Let me. I'm closing.
We asked the question.
Yeah. Let me just. I'll close my whiteboard. I don't need the whiteboard. I explained everything I needed. So you agree that the angular momentum is just mvr, right? Of that electron. Yes or no?
Sure.
Okay. So you agree that, right? You would grant me under classical mechanics, you would grant me the mass of the electron as a quantized quantity, the velocity of the wave. Let's assume it is quantized. It is some number, right? Between two silver atoms, the electron's wave is waving around at a certain velocity. That velocity cannot change. If that velocity changes, then it's different energy, different kinetic energy, different energy. So it's a different atom. It's a different shell. We're assuming that we cannot distinguish any two silver atoms. We're talking about room size silver atoms. We cannot distinguish any two room size silver atoms except for the orientation of this waving of this electron, right? Yes or no? Mr. Lowry.
Sorry, I'm getting this.
So just mute. Look, if you want to have a discussion with me, just mute anyone who's distracting you. What's the point?
No, I'm distracting myself with this.
Okay, so you don't want to talk?
No, I guess we can talk. I can try to concentrate.
What do you mean try to look, you either want to have a discussion or you don't. I mean, it's up to you. So I'm fine either
Yeah,
way.
I finished messing around with you.
You finished messing
the
around
board.
with me? What does that mean? You want to continue talking or
No,
not?
I was messing around in the board.
Okay, do you want to talk or do you want to not talk? It's up to you.
Yeah, let's talk.
All right. You want to ask questions? Because I was speaking and I don't know where you're at. So why don't
We
you
don't
ask?
know where you're at.
Okay. Muted. Let's continue. So,
What,
Mr.
did you
Lowry,
mute him? What?
yeah.
Oh my
Yeah,
gosh,
yeah.
like-
And I will leave. Look, I'm not here to waste my time. I'm sorry. So sorry. So, Mr. Lowry, do you want to continue?
Yeah, I can continue in a very small bit.
In a what?
In a very small bit.
What do you mean? You're not ready to continue?
Mr. Slave.
All right.
I don't think
Mhm.
I don't think what you're talking about still fits classical mechanics, because even laminar flow,
Mhm.
I don't think that assumes quantized.
Look, we'll work backwards. We'll see what you granted
Yeah,
me.
let's do that.
So for now, we'll assume laminar flow. You know, at the end, we'll see. Okay.
Yeah.
All right. So do you have any questions? Because I mean, just ask me questions. Because I don't know what else to say. Because I'm.
I had questions about the laminar flow, but if I need to grant you that, and that's the question, then okay.
But do you have any questions about the stern-gerlach? That's the question. Because I don't know. Because
I had a question about the laminar flow.
Yeah, I said let's grant laminar flow. Do you have any other questions in order to explain stern-gerlach?
I had a question, actually. Hold on, let me get the stern-gerlach. I had a question of how would you explain that the spatial orientation of the angular momentum is quantized? But I guess the answer is let's just grant you that.
No.
And then let's ask the next question.
No, I didn't say you need to grant me that. So what I'm saying is that the orientation is random. I don't need you to grant me the orientation. I need you to grant me the magnitude of the vector, right? The magnitude, MVR. We're assuming M, we're assuming V, we're assuming R. So we're assuming MVR. We'll come back to discuss MVR. We'll come back.
Okay. So I think you're building to a quantization of angular momentum right there.
Wait a minute.
Yeah, I can grant you that.
No, I didn't ask you to grant me angular momentum. I asked you to grant me the magnitude of the vector, not the magnitude, the MVR, yes, not the orientation. The orientation, I'm completely free. That we can leave the silver atom to point the L vector in any direction. So I don't.
Sure.
So do you understand now the stern-gerlach result?
I don't, because you just said that you don't want me to grant you the stern-gerlach, which is the quantization of the spatial orientation of
I
angular
told you
momentum.
no. I don't need no.
Again,
I told you multiple times. I told you multiple times. I don't need you to grant me the orientation, just the magnitude. We'll come back
but
to.
then you didn't you didn't then go and lead me to the orientation in any
Yeah, the
way.
orientation is free. The orientation
It's
is
not free.
yeah. In my, I don't need you to grant me any orientation. It could point.
Yes, yeah.
The vector can point any which way. Just the magnitude that I need you to grant me temporarily. We'll come back to show
Yeah.
why
Okay.
the
I
magnitude.
can grant you that.
So, do you now understand the results of the stern-gerlach? Yes or no?
No, because the stern-gerlach has to do with the spatial orientation, and you didn't get us there yet.
Right. Okay. So stern-gerlach, all electrons are either up or down. Nothing in between. There's no spread. So let's imagine now, instead of a silver atom, let's use tiny magnets. Let's throw in tiny magnets into the stern-gerlach experiment, into between the magnets. And let's assume each tiny magnet for now. Let's ignore the angular momentum. We'll come back to the angular momentum, but they, of course, they have magnetic moment. Right? Do you agree? We're going to throw in tiny magnets, identical magnets, into the stern-gerlach experiment, right? Completely classical. Do you agree that this is completely classical? We're going to throw in tiny magnets into stern-gerlach. Do you agree that it's classical?
Sure.
Okay. Do you agree that all these magnets are going to either go up or down? You're not going to get a spread. Do you agree or disagree? This is classical mechanics. This is classical.
You will have to make your case for that.
Wait, this is classical. So under classical,
Yes, but you will have to make your case.
wait, okay, I don't have a problem, but so right, when a magnet, right, you can see this with a compass. This is now, we're having a classical discussion. This is completely within classical physics. So a compass aligns with the Earth's magnetic field. Do you agree with that? Yes or no?
Yeah.
Okay. So magnets align with magnetic fields, right? So when I throw in tiny magnets into the stern-gerlach experiment, they will align with the magnetic field. Agree or disagree?
Wouldn't they also at the same time create magnetic fields of their own?
Yeah, but they're tiny and weak relative to the strong, stable, stationary stern-gerlach setup, right? Let's assume that the magnetic field of the stern-gerlach is huge, and these tiny magnets, they're super weak. They're tiny. They're specks of dust. Each one is the size of a speck of dust. Right? Let's assume we actually took powder, right? We took a magnet and we turned it into powder. So each dust particle is a tiny magnet. And each one is super weak. And we're throwing them in one at a time. So you agree that each tiny magnet will align with the huge stern-gerlach magnetic field, right? Are you there? Mr. Leroy?
What is the stern-gerlach magnetic
Excuse
field?
me?
What is the stern-gerlach magnetic field?
It's just a magnetic field. It's a non-uniform magnetic field. Let's say pointing up. I think their magnetic field was pointing up. B.
Okay, yeah.
Mm-hmm.
So what
Mm-hmm.
what makes the stern-gerlach magnetic field? Is it the tiny magnets, or does it already exist before the tiny magnets?
No, it's an electromagnet. I think it's an electromagnet. So they can turn it up. They turned it up. In the beginning, it was they first they throw in the tiny magnets with no magnetic field, to calibrate. Then they start turning up the magnetic field, and as they turn up the magnetic field, they saw that the silver atoms were beginning to spread more and more. So I would say that is what would happen to tiny magnets. Do you agree or disagree?
I probably wouldn't know either way.
Wait, this is classical magnetism. I'm not saying anything, right? You agree that compasses align with the Earth's magnetic field, right?
I do.
Right. So this is, how is this different, right? This is just a magnetic field, and these are, I'm throwing in tiny compasses. Then why would they not align, right?
I don't think tiny compasses is right. Like, do you have
Well, that's a given.
a magnet stick in a fluid or something?
No fluid. There's no fluid here. This is the stern-gerlach experiment. Instead of throwing in the silver atoms, I'm going to throw in magnetic powder, magnetized powder, a magnet that I turned into powder. I'm going to throw one powder particle at a time. You agree that it will align with the stern-gerlach magnetic field, right? Just like a compass. How would it? It's basically, it's just a tiny compass, right? Are you there, Leroy? Leroy, are you there? I don't. What's?
I'm not sure if I'm Roy.
Mr. Leroy, do you want to continue this discussion?
I was thinking of Susi Koiraro.
So you don't want to continue the discussion? So are we done?
I'm here. I'm just getting tired. It's too late here.
Do you want to continue the discussion?
Sure.
Do you have any questions? I gave you a thought experiment with tiny dust-sized compasses that I'm throwing into the stern-gerlach strong magnetic field one at a time. Do you agree that this tiny compass will align with the stern-gerlach huge magnetic field? Yes or no?
How exactly would an atom be like a compass?
I'm not saying atom. I'm saying it's a dust-size compass. It's a tiny. I took a magnet and I ground it into magnetized powder, and I'm taking one powder dust particle. It's a little compass, and I'm throwing it into the stern-gerlach experiment.
So we're still talking about the silver atoms.
No, I'm talking about what? No. I put that aside. Now I'm talking just classically about classical magnets. Nothing more. Just a tiny classical magnet.
So we're talking about
Excuse me?
Okay.
Excuse me?
All right. I can roll with that. Sure.
So you agree that
what's the argument?
Wait, do you agree that we will reproduce stern-gerlach using this powder, magnetized powder? You agree that we'll get either up or down, right?
No, I do not.
Okay. What do you mean?
Here's my reason.
Yes.
You're using tiny compasses. You're not using silver atoms, which is what they use in the stern-gerlach.
No. I'm talking about just the. You agree that we reproduce the results using this powder. I'm not talking about the silver atoms. I'm talking about actual, right? This powdered magnet.
So we really reproduce the results in the stern-gerlach when the results of stern-gerlach were using silver atoms and we're not using silver atoms.
Hold on. What I'm asking you, look, you're not answering my question. I need you to answer the question yes or no. Do we or do we not reproduce stern-gerlach using this magnetized powder? Yes or no?
No.
Okay. Why not? I mean, because
yes.
Mhm.
in the stern-gerlach
No.
experiment, the silver atoms
No.
were
Look, okay, you're
demonstrated
refusing. Okay,
that
you're
they
refusing.
hold
Okay, no. You look. Don't waste my time. You're refusing to answer a simple question. This is a simple question. You're refusing to answer.
Hold on.
No, I'm done. Thank you so much. I don't
I
want to
guess
waste
you
my
are
time.
done.
All right. This is incredible. So you show to people. This is incredible. Like you would not believe it. People are so resistant. They're so resistant. No, you cannot explain the universe. The universe must be unexplainable. How can you take this from us? It's a magical universe. You cannot take it from us. And I'm taking this magical universe away from these children, and they want to keep believing it's a magical universe. It's unexplainable. It's qubits. It's quantum computing. It's cats and dogs. They're alive and they're dead and they're both and they're neither. Everything. That's it. And you want to nail them down? No, you're not going to nail them down. They don't want to be nailed down. And this is a discussion. It's a simple discussion. This is not a debate. This is a discussion. So he opposed me at every step. He opposed me. And this is one of the first times I'm able to have a discussion. But usually they all play games. They don't even want to talk. Unbelievable. But this is incredible. This is very good. This is very good. Maybe I should stop the recording because this is just amazing. I think I'll stop the recording. Maybe I'll go grab a bite and I'll be back. I think this was very good. Amazing. So let's recap. This is so good. I mean, this took me. This was my biggest challenge. When I heard of the stern-gerlach, something bothered me about it. From the beginning, I was like, something sounds simple. It's got to be simple. I mean, actually, we can even see my first discussions with Chinas. So we can roll back the tape to the discussions with Chinas introduced to me stern-gerlach. And I was, in the beginning, I said, okay, I look into it. I think I understand it. I don't, nah. And then for a while I didn't. And then now that I know, I guess a little bit more, and I know this, I'm studying physics and learning things and studying and learning and thinking, and then it came to me. And look at the resistance. Look at the resistance. He's unwilling to consider tiny magnets. He knows that tiny magnets reproduce stern-gerlach. He knows that he is doomed. He knows this is not even a debate. Unbelievable. Let me try and find that. Maybe we can search here for Stern. Let's enter Stern. No Stern. How do you search this thing? Discord is so terrible about searches. This is water. I don't know how to search. Let me do maybe search for Stern. Nothing. And I'm listening to physicists. You know, like you saw the video from yesterday. Oh, the quantum physics, quantum computing. The universe is conspiring again with the universe. The universe is always conspiring. The universe. The spin. I mean, the universe doesn't conspire about the mass of the electron. The universe doesn't conspire about the charge of the electron. The universe is conspiring about the spin. The spin, the spin, this universe is going to spread the spin, and we could use quantum this and quantum that in the universe. Give us trillions of dollars. We're geniuses, and the Dirac notation and the probability and mathematics and probability, and let's make degrees and give us more grants and more money and probability. Nonsense. Complete nonsense. You agree that if I throw in tiny magnets, you agree that I reproduce stern-gerlach. You agree with that? Yes or no? He's unwilling. No, he's not going to answer the question. Not going to answer the question. No, silver atom. Silver atoms. Well, okay, I'll come back to silver. This is classical. This is classic. No, I'm not going to discuss it. No. Silver atom. But I'm asking again and again and again. I'm playing games. I'm playing games. I'm going to play games. This is gambling games. You don't want to have a discussion? Like in the beginning, the quantum. At the end, I'm playing games. This is so funny. I'm playing games. Everything is a joke. When they lose a debate, it's a complete joke. Oh, they didn't mean to. It's not a debate. They never debate when they lose. The loser never debated. No, he never debated. He never tried to convince you. I'm not even going to try to convince you. No, I'm not going to try to convince you. No. Yeah. The loser never tried to win by, anyway. Amazing. It's unbelievable. It's like I thought I'm going into physics, I'm going to prove things and teach people. I'm going to, use my brain, and I'm going to show them how smart I am, and they're going to say, wow, you're a genius, and I'm going to be famous. No. They're not. They're not going to talk to you. They're going to laugh at you and do nothing but laugh at you. They don't care. What do they care? Stern-gerlach, stern-schmerlach. What do they care? They don't care about physics. They don't care about understanding the universe. They're not curious. Nothing. It's all personal. It's all personal. It's just a tribe. They just want to be together, hang out, make fun of this guy. That's it. And if this guy is making sense, no, we're not gonna entertain a sensible discussion. Anyway, I don't know if I can find where we had this discussion for the first time about the stern-gerlach. I don't know how to do a search. When I do Control F, it brings this over. Search option. No, maybe just an experiment. Even exp doesn't show up. No results. New, old, relevant. There's no results. How do you do a search? History? I want to search. I want to do a simple text search. Mention, has, before, after, pinned. There's no way to do, give me a Control F, not of this thing. I would just want to do a search in the browser. Can I ask the browser for a search? Find and edit. Find. Stern. No stern. Oh. Ger. Where's no gerlach? Oh. No experiment. Experiment. Experience, yes. No experiment. So look. Even the word look doesn't show up. So maybe the conversation wasn't private. Maybe it was on the server. Maybe it's a server conversation. Now there's no Control F. my god. Let's try this. Control F. Stern. So how many sterns? This is all the results of stern. There it is. So jump to this. Okay. So this is like, now we are the middle of October. And this is August. So it's 2 months ago, 2 months and something. So I think this is probably the first time. So I wasn't even looking at stern-gerlach. I was still doing black body maybe. Stern-gerlach is electric, neutral silver. So let's assume it's 100% uniform, but first I have a question. Anyway, I didn't know how to explain stern-gerlach. I did not know, and I let it go. You know, I always let go of things. I don't like wasting time or even spending time trying to understand something. So I let things come to me. Like I study, I talk about whatever I know, I debate. Whatever I don't know, I don't debate. And yesterday, I don't remember at what point, I finally realized I can explain it. It's simple. And then I went and I listened to that guy with the physicist period on his shirt with the long hair. How the universe has conspired from letting us understand stern-gerlach, whatever. Amazing, amazing, amazing how they don't want you. No, they're not going to talk about whatever you can make sense of. They don't care. Everyone says you cannot understand stern-gerlach. Stern-gerlach, you cannot understand it. That cannot be understood. This is the gods. The gods will not let you understand the stern-gerlach. The gods said you will not. And Einstein didn't understand it, and I don't know, nobody understood it. And here I am, I'm looking at it. Okay, it took me 2 months, got it, done. And I'm talking to people, let me explain it to you. No, we're not gonna let you explain it. No, you're not going to explain it. No, you're not. We're gonna laugh at you. We're gonna paint on your whiteboard. You're not going to explain it. We're not gonna give you the honor. No, we are not going to explain it. That will not happen. We will claim that the universe is even weirder than we thought it could ever be. The universe is weird. The cats and the dogs, they're both alive and dead. You cannot take that away from us. And the stern-gerlach, you cannot explain it. You cannot explain it. It's unexplainable. All right, quantum computing, give us trillions of dollars. But you do agree that we can reproduce stern-gerlach with just magnets, right? You agree that if we throw in tiny magnets, they're going to align, right? Just like a compass. Like I'm making it so simple that he can't. No. Silver atom. I'm not going to answer the question about the magnet. I don't know. I don't know compasses. I don't know enough magnetism. Okay, but you agree that a compass aligns with Earth's magnetic field. Yeah, sure. Even that he didn't say yes or no. Yeah, sure. Okay. Then I'm throwing in a tiny magnet into the stern-gerlach. It would align. You agree? Let's talk about the silver atom. Oh, so you're refusing to answer the question. Let's talk about the silver. Okay, okay, fine. We're done. Have a great rest of your day. That's all I wanted. I don't need them to concede. They will never concede. People don't concede. So that's a given. That's fine. I'm not here to get a concession. I'm here to get my theory criticized. I just want you to do flip-flops in the air trying to criticize my theory. Say everything and anything about my theory, trying to discredit it. That's what I'm here for. And all they can do is poop their pants and refuse to answer my questions. So, good. It was a good day. Yesterday was a good day. Today was a good day. I want to have a short video. I think it's good separate video. I don't have anything to add. I mean, so if it comes to it, if I need to convince someone that the stern-gerlach is simple, just think of a tiny magnet. So because the whole problem is the quantization of the magnitude, but the magnitude depends on m and on you agree that an electron has a magnitude of mass, right? You agree with that. You agree that it has a magnitude of charge. You agree with that. Okay, so from those we can work out that it has certain angular momentum. From that we can derive it. For now, grant me, we'll come back. I gave you the notion how we're going to prove it. Basically Bohr with the ether. It's really very simple. Grant me that. Okay, now let's go to a simple magnet. You agree that with a tiny magnet, if we throw a tiny magnet into stern-gerlach, you agree that since compasses align with magnetic fields, you agree that the tiny compass will align with the stern-gerlach, right? You agree. Let's talk about the stern-gerlach. Let's talk about the silver. Wait, I need you to grant me classical physics. Grant me classical magnetism. Grant me first grade compass. You agree with first grade compass experiment. Grant me a first grade elementary school first grade compass experiment. I'm not asking for much. No, we're going to talk about the silver atoms. Okay, all right. You don't. So I'm right. The stern-gerlach has a simple classical explanation. Because the whole problem is the spatial component. They couldn't, like always, they confused themselves that they thought that the angular momentum vector is quantized. It's a spatial quantization. Jesus Christ! Born told them spatial quantization. Stern-gerlach, that's what they were looking for. Spatial quantization. They proved spatial quantization. Are you people out of your minds? Who said spatial quantization? Who said that? What are you talking about? I just need quantization of magnitude. I don't need quantization of orientation. I don't need that. The magnet gives you the quantization. It's not quantization. The massive magnet causes the alignment either up or down. What's the question? It's so straightforward. No, we're not gonna talk about magnetism. We're gonna talk about the silver atoms. Wait, but you agree that a tiny compass is gonna align with a huge magnetic field of the stern-gerlach? No, I'm not talking about that. We're gonna explain the silver atom. Wait, can you grant me this? I need to build the building blocks on. I need to confirm I have a building block to build on in this conversation. Not going to grant it. Huh? Okay, so you don't. Because he knows this is the final nail in the coffin of this nonsense. Quantum computing! The qubit! I'm a genius! I have long hair. I I say physicist on my shirt. I'm a genius mathematician. It's probability. The universe is conspiring. Okay. All right. I can't stop you. I can't stop you. You're a free person. You can do whatever you want. You can say whatever you want, do whatever you want. I can't stop you. I can offer you what I see as is a very simple mechanical explanation to the stern-gerlach experiment. Really straightforward. You don't need quantum mechanics. You don't need quantum nonsense. You don't need woo-woo chickens and eggs existing and not existing. You don't need any of that. You don't need universes. You don't need conspirations, conspiracies. You don't need. Here's a simple explanation. Here is the cause of the stern-gerlach. Questions? No, they don't want to hear it. Fine. It's fine. Very nice. Okay, I'm gonna stop this because it's like it's a perfect one topic, and this is already the topic that I already put in. Can we explain the stern-gerlach experiment using classical mechanics only? I think I've made my case. I mean, they wouldn't let me complete my case. Of course not. They don't want me to think through. They're not interested in thinking through all the steps. But I think I've made enough of a case, and it's all very straightforward. There's nothing interesting in the stern-gerlach experiment. It's just I don't know why people couldn't figure it out. I don't know. This is really so simple. Took me 2 months, basically 2 months since I heard about the stern-gerlach. 2 months and 2 weeks, whatever. Done and done. It's behind me. It's simple, mechanical, classical. There's no, like, quantum mechanics is a joke. It's a complete joke. Very sad. Very sad. We're definitely doomed. I mean, we're doomed. We're just doomed. I don't see. We're not gonna survive it. This is crazy. Okay, there's 2 people watching. Thank you very much for watching, but I just want to cut this short. So I'll be back later. I'm going to leave now. Thank you so much. Have a great rest of your day, and bye-bye.